Welcome back to your YouTube channel, the channel for chemical engineers. In this deep dive, we walk through the engineering rationale behind instrument air package design, anchored to JIP 33 and ANSI/ISA 7.0.01, the two specs you will hit on any real project. Before we touch sizing math, let's lock in the design fundamentals. What an IA package actually is, what air quality it must deliver, and which standards govern that quality. An IA package is really two halves: compression on the supply side and treatment plus storage on the delivery side. Undersize or misconfigure either half, and downstream instrumentation pays the price. ANSI/ISA 7.0.01 sets the bar. PDP at least 10 degrees Celsius below the coldest expected line temperature, never above 4 degrees Celsius at line pressure, and 40 m as your particle ceiling for typical pneumatics. Two non-negotiables: lubricant content held as close to zero as possible and capped at 1 ppm, and zero tolerance for corrosive suction gases. Both will destroy desiccant beds and valve internals. Now, the part most engineers underestimate. Pressure dew point is not the ambient dew point you read off a psychrometric chart. Compression changes the game. Compress the air, and you compress the moisture with it. A minus 40 degrees Fahrenheit PDP at 100 sig is a far harder duty than the same minus 40 degrees Fahrenheit at atmospheric, because the partial pressure ratio is doing the work. 3 steps. Pull saturation vapor pressure at ambient from steam tables. Scale by RH to get actual vapor pressure. Then apply the line to ambient pressure ratio to find the equivalent saturation at line pressure. Run the numbers. 68 degrees Fahrenheit and 40% RH compressed to 100 sig drives the line dew point to 104 degrees Fahrenheit. That is why safety critical service needs a regenerative dryer, not a refrigerated unit. With PDP framed, let's compare the dryer technologies you will actually specify on a datasheet. 3 options: refrigerant for modest plant air PDP, membrane for small point-of-use loads, and regenerative desiccant when you need minus 40 degrees Fahrenheit to minus 100 degrees Fahrenheit PDP. That's the IA industry standard. Twin tower design. One tower absorbs while the other regenerates. Budget 15 to 20% of capacity for purge air, and pick your heat source: purge, internal heater, or external blower, based on energy economics. Activated alumina is the robust workhorse. Silica gel handles standard process air but is moisture sensitive, and molecular sieve is what you reach for when the spec sheet calls out minus 100 degrees Fahrenheit PDP. Vendor ratings assume 100 sig and 100 degrees Fahrenheit. Higher operating pressure helps you 1.17x, but higher inlet temperature hurts a lot, 0.64x, because vapor pressure scales non-linearly with temperature. Apply those corrections to a 100 SCFM dryer running at 120 sig and 115 degrees Fahrenheit, and you are left with only 75% of rated capacity. Always size from corrected numbers, never nameplate. Sizing the dryer is half the story. Now let's talk about what SCFM actually means on the supply and demand side, because the units lie if you're not careful. Standard is not standard. The gas industry uses 14.5 SIA and 68 degrees Fahrenheit. Other references use 14.7 SIA and 32 degrees Fahrenheit. Density shifts with both, and that determines the real mass flow you deliver. Mix those bases, and a nominal 10 SCFM supply meets only 92% of a 10 SCFM demand. Specify base conditions explicitly on every datasheet, or you will underdeliver in the field. Humid suction air robs you of dry air partial pressure. At 100% RH and 68 degrees Fahrenheit, effective suction drops from 14.5 to 14.16 SIA. That is compressor mass flow you do not get back. Now the compression side: what to pick, when to pick it, and why rotary screw usually wins for IA service. Centrifugal is cost-effective at large sizes, but discharge varies with load. Reciprocating gives strong multi-step turndown but at high first cost and maintenance. Rotary screw is compact, oil-free, and typically the IA pick. Why rotary screw for IA? Oil-free delivery keeps the downstream desiccant alive. VSD gives capacity control. usually limited to 50% turn down for bearing lubrication, and it tolerates start-stop cycling with a properly sized receiver. 4 control states to model: load, unload, overrun, and stop. The overrun timer protects motor windings from rapid cycling. Do not strip it out, chasing energy savings. Last block: how you store the air and how you get the water back out without losing pressure or flooding instruments downstream. Receivers by you ride through during compressor cycling or demand surges. The math hinges on a defined pressure band, and if makeup supply is available during drawdown, subtract it from the net consumption term. The variables you will plug in: drawdown time in minutes, receiver volume in cubic feet, upper and lower pressure band limits in SIA, and net air consumption in SCFM. Receivers by you ride through during compressor cycling or demand surges. The math hinges on a defined pressure band, and if makeup supply is available during drawdown, subtract it from the net consumption term. The variables you will plug in: drawdown time in minutes, receiver volume in cubic feet, upper and lower pressure band limits in SIA, and net air consumption in SCFM. Load at 120 sig, unload at 130 sig, minimum process pressure 100 sig. That gives you a 20 psi usable buffer, which is your insurance policy against trips during surge demand or a compressor failure. Condensate accumulates at the receiver bottom as the air cools to PDP. Drain traps must discharge liquid without bleeding air, and they need a balanced line back to the receiver or they air bind and stop draining. Run the mole balance. 500 SCFM at 70 degrees Fahrenheit and 70% RH produces 2.89 gallons per hour of condensate. That is the duty your trap and disposal system must handle. Undersize either and water reaches the instruments. As we are nearing the end of this training, let's go through the vendor process flow diagram for instrument package. The diagram also shows the plant air being taken upstream of the air dryer. Sometimes, the compressor can be part of nitrogen package, where instrument air is passed via PSA unit to remove oxygen from instrument air. Nitrogen package details will be covered in future trainings. Engineers must develop interface of vendor package with rest of plant. Engineers, this is one of the example of vendor, piping, and instrument diagram of instrument air package. This diagram shows the detailed arrangement of equipment and also shows the piping, valves, and instrument arrangement of the package. To recap, get the thermodynamics, the compressor selection, and the storage sizing right, and your IA package protects the plant for decades. The further details of such package are available as paid consultancy from the channel owner. Finally, please do like and subscribe this channel for more such interesting videos on chemical engineering topics. The basic act of liking and subscribing encourage author to make more videos, apart from various consultancy assignments. Thanks a lot for watching this video.